Okay, everybody, I'm going to put out a video, handout that goes with this, but so you'll be able to see it. You can follow along with the handout. But it's sort of I guess it's a thought process you can go through as you're adding or subtracting rational expressions with binomial, trinomial denominators. Now, so you can follow the handout. I'm going to put it out there. I'm going to send it to you. So how would you approach this? Well, what I would start with is, we've got all our numerators and denominators. It's factor them all. Always factor. If you're wondering where to start when you're adding, subtracting, or doing anything with rational expressions, factor all your numerators, factor all your denominators, and find the non-permissible values. You can put this on pause, and you can do that right now. Factor the numerators and the denominators. Now, top one factors out to x plus 3 times x plus 4. The bottom one here, that factors out to x plus 3 times x minus 2. This top one factors out to x plus 5 times x minus 1. And this bottom one factors out to x minus 1 times x plus 2. Now we'll find our non-permissible values. The values that, if they substitute in x, we get 0 in the denominator. From this denominator, if I was to put a negative 3 into x, I'd end up with a 0 in the denominator here. So we know that x cannot equal negative 3, or from this one. If I was to put a 2 into x, I'd end up with a 0 in the denominator. 2. From this one, 1. And from this one, if I put a negative 2 into x, I'll end up with a 0 in this bracket, and we'll end up with a 0 in the denominator. So those are our non-permissible values. Now, next thing is simplify each rational expression if you can. Sometimes it'll be possible, sometimes it won't be. So let's look at this one. We have a rational expression, subtraction side, and another rational expression. Well, is there anything common top and bottom here? Yes, there is. An x plus 3 in the top and the bottom. So when we simplify it, we've got x plus 4, and I'm going to keep brackets around it, over x minus 2. Subtraction side. Anything common top and bottom here? Yeah, an x minus 1 in the top and an x minus 1 in the bottom. That leaves me with x plus 5 over x plus 2. Sometimes they'll be able to be simplified, some might not be able to simplify, but in this case they would. This is a general note to follow. Now, we can subtract these two rational expressions. What's the lowest common denominator? A combination between x minus 2 times x plus 2. LCD, x minus 2 times x plus 2. Okay, to continue on with that note, I just transferred everything up to the top here. Now the next part, now that we know the lowest common denominator, we want to express each as equivalent fractions, but with the lowest common denominator as a denominator. So we're going to express x plus 4 over x minus 2. We're going to come up with an equivalent fraction or expression, but that has the LCD as a denominator. What's missing from this denominator that we have down here? The x plus 2. So we're going to multiply top and bottom by x plus 2. Leave it in its factored form right now. We'll have x plus 2 times x plus 4. X plus 2 times x plus 4. And then x plus 2 times x minus 2. We have it down here, our lowest common denominator. Now what's common from top and bottom here? Sorry, what's missing from this denominator that we have down here? The x minus 2. So we're going to multiply top and bottom here by x minus 2. Get an equivalent fraction. X plus 5 times x minus 2. Over x plus 2 times x minus, over the LCD. Good, now we have equivalent fractions, but expressed with a common denominator. Now what would we do with fractions? Well, if we had a common denominator, we'd subtract the numerators over one denominator, and that's what we're going to do here. Subtract the numerators, leave them in their factored form right now. x plus 2 times x plus 4 subtraction sign, subtraction sign, times x plus 5 times x minus 2. So we're taking the numerators and subtracting them. Keep track of that negative sign outside the bracket. Over one denominator. X minus 2 times x plus 2. Leave them in their factored form right now. Okay? Next thing you'll do is you're going to expand and collect your like terms in the numerator, in the top. Okay? FOIL, subtract sign, FOIL. Okay? We'll put it on pause as I transfer this again.